So I just want you to, at the end of this session, to feel comfortable with federations. Look at it as something you want to keep track of and watch it progress. Maybe use it. And then know where you can go when the time comes to implement it, that there's help for you and you can get this thing rocking and rolling. Anybody else? Anybody want a poster for their office wall on SQL Azure federations? Ma'am, do you want a poster? No? No? You do. Good. Yeah. You want a poster? I'll come around to you. What time is it? Should I be starting? Is it 2:40? 41. 14. I should say 14:41. Okay. It's not 5:42 a.m. That's what it is in San Diego time. Anybody been to San Diego? Yeah. Nice. Yeah? Did you guys surf? No? Did you surf when you were there? No? You're missing some great surf. They sing songs about it. Like where I live in La Jolla, the Beach Boys sang a song about how good the surf is. So if you ever get a chance to go, make sure you rent a board and try it. Do you want a poster? Yep. It doesn't even matter what it's about. No, you just want it. Okay, yeah. It's real. What? You have failed. You've been in your hotel for 3 days? Been busy? Yeah. And you came here to see me. Nice. Okay, I appreciate that. The poster's on SQL Azure Federations, and it just kind of introduces it to you. You can just remember me. No, that's not what it's for. It's just to put up on your office wall. So if you want one, let me know. I have 4 left. I didn't think I'd give these out, by the way. Oh, you want one? No, nice. You know, I'm grateful you guys all kind of congregated on this side of the room, by the way, because I like to walk around and talk because I bore myself and I'll fall asleep if I sit behind the podium. So it's nice to have you guys all in one place. Do you want a poster? Yeah. So only 3 of you have been to San Diego. Well, hopefully you all get a chance to go. I'm proud of my city. It's a beautiful city, and it's a fun place to be. Way better than LA. Way better. Don't judge San Diego by Los Angeles, which is a terrible, terrible city filled with terrible people, including my sister. But we play this game in the United States called baseball, and the Dodgers are the rival team. Just a bunch of miscreants and thugs and really killers. I'm not afraid to say it. Really, they're murderers up there that just terrorize our fans and hurt our feelings with their name calling. So I'm going to go ahead and start. And if people are late, we'll just make fun of them. So my name is Ike Ellis, and I'm a SQL Azure MVP. I run the largest user group in San Diego called the San Diego Tech Immersion Group. We're like a technical book club. We get all of our members together, and we read the same book for like 4 months. But we only make them read like 100 pages a month. And then at the end of it, we have usually the author come speak to them about the topic that they just read. My friends and I are all MVPs, and we sit there and they read on their own time. And then they come to our meeting, and we just answer their questions on the topic. Like we just finished up Entity Framework. We've done WPF. We've done Transact SQL. We're about to start CSS, jQuery, and HTML5, a track of that for like 6 months. It's kind of fun. If you want to learn more about that, that's sdtig.com. I'm proud of it. We've got a lot of good members, and I love doing it. It's really, really fun. The topic that we're going to talk about today is SQL Azure Federations. Specifically, we're going to talk about building scalable apps in federations. And so we need to frame the problem, and we need to talk about why federations is the solution to the problem. But before we do that, I just want to do a quick overview of SQL Azure. First of all, who's using SQL Azure? Who uses it? 2, 3, 4, 5. OK, 6. So 10% of you are using SQL Azure, maybe a little more. Okay. If you want to use SQL Azure, you can use it for free pretty easily. If you're MSDN subscribers, you get a free account to Azure and SQL Azure. If you want to get a 90-day free trial, you just need an email address, and that's about it, and you're using it for 90 days. Really, if you're paying for SQL Azure as you're trying it out, you're doing it wrong because there's so many ways to get this thing for free. And there's a link here in the slide deck, so if you download the slide deck, you'll get it. SQL Azure has been renamed, and it's going to be the bane of my existence all day today, so I hope you'll have patience. But it's been renamed to Windows Azure SQL Database, which you will never hear me say again because I will forget, so I promise. Maybe next year. I'm still writing 2011 on my checks, so I don't know. I'm just kidding. I don't write checks. Who writes checks? OK. There's been a SQL Azure price reduction. It used to be about $10 a gig to use SQL Azure, but now it's way cheaper than that. It can go all the way down to $1.51 a gig. Notice that there's a gig limit in SQL Azure. You can only have databases right now up to 150 gigs, which is actually pretty large. So probably for most of your apps, you can start thinking about SQL Azure and getting those databases up in the cloud where hopefully you're saving a little bit of money and you've got a little less hassle. And then before the talk begins, I just want to show you real quick SQL Azure architecture so we're all talking on the same page. And that is, when you connect to a database in your application right now, you specify a connection string, don't you? Who here are developers? Who writes code? Oh, nice, my people. You're all here. OK. So when you specify a connection string, you specify 5 things, right? What are those 5 things? Server name, yep. Catalog, which is database, yep, that's right. Username and password, yep. And what? And instances and server name and provider, right? OADB or ODBC or whatever the provider is, right? OK. So when you specify your server name, you think you're talking about a physical server, like you can point to it. But in SQL Azure, it's a lot different. It's that server name is not a physical box. It's a logical entity. And underneath that server name is actually 3 physical machines. And in federations, it could be more. It could be a lot more. So what you're getting in SQL Azure is you're getting a primary machine that hosts your database. And then you're getting 2 secondary machines with secondary backups of those databases. And it's all built automatically into the billing cycle. You can't turn this off. You don't even know it exists. So you're immediately fault tolerant and replicating. And it's important to know that, particularly as we talk about federations. So here's our agenda today. It's a big agenda, and that's why I'm going to talk fast. But we're going to talk about scaling and why scaling is hard in relational databases. We're going to introduce some vocabulary about federations so you get a good understanding of federations. Who's using federations? Anybody using it right now? Nice. Perfect. You're in the right place. All right. And then we're going to build an app. And that app, we're going to do a whole lot of demos back to back to build that app and get it up and running for you. And then we're going to talk about some good practices. Notice I didn't say best practices because we have been around this before, haven't we? We know that my best practice is your worst practice, right? So I'm just going to give you some guidance that I've learned in dealing with federations. And then we'll look at a roadmap. And then we'll look at the Ike roadmap, which is I can give you the Microsoft roadmap, and then I can give you what I think it's missing. And I'll do that at the end. And then I'll show you a contact me, and we'll open it for questions, and we'll go as quick as we can. So this is a typical web application, web server front end, middle tier, database back end. You're coding away, and you put this thing live. And if you're like Twitter, you code it very poorly. And then you go live, and you realize you've got millions of users. And you think, oh, no, I have done a terrible thing. And so you realize that you didn't scale this thing up well enough. So you hope that you can scale up, which means that you can get your servers bigger. But usually what happens is you bought your servers too small, and this guy decides he needs to use it, and you realize you need a bigger server. We need to scale. We need a bigger scale. We need to scale up. But unfortunately, servers only go so large. So instead of scaling up, we would like to scale out, which means we'd like to add servers to our design. and hopefully achieve a few things. The first thing we're hoping to achieve when we add servers to a system is we want more hardware. We're throwing hardware at the problem in hopes of improving our performance and giving the customer a better experience. We're hoping that that scaling is invisible to the application, meaning I want to be able to throw servers at it and not have to rewrite stuff. Can you imagine if every time I threw a server at something I had to rewrite large portions of my code? I would dread doing that. Hopefully, if a server goes down, another server can take over. That's fault tolerance, and we use that for disaster recovery. And the other thing is if I have one customer that pays me a lot of money, I have a $1 million a year customer, and he says he wants his own server, I want to easily be able to give him his own server without rewriting the app. So now that we've framed scaling out, if I were going to scale out, actually, real quick, one of the big reasons why we scale out SQL Azure specifically is that we have a 150 gig limit that I just told you about. So you come up on that 150 gig, and we're just going to stop operations. We're going to close our doors because we hit the max database size. We don't want to be doing that. So if we hit the max database size, we want to be able to throw servers at the problem. One quick thing: who's managing data around 150 gigs right now, or higher? Who's got data higher than that? Okay, who's got the most data in the room, actually? Who's got SQL servers with a tera on it? Raise your hands. A terabyte. One person does. Okay, so you're the big guy in the room. How large?
People doing it, so I don't have several terabyte, but not sure how big now.
Oh, some people are managing it at several terabyte. Okay. So I manage a couple of databases that are around a tera, and what I found in managing those is that there's a lot of wasted space. I've got records dating back from 2000 that I've done analysis on and nobody ever looks at. Nobody ever looks at data in my database older than 24 months, and very rarely do they look at data older than 13 months. They're really only looking at hot data. And the blob storage that I have, they tend to throw stuff in there and then never look at it again. It's just a placeholder. They don't tend to look a lot. So I discovered that in my 500 gig databases, probably only about 40 gigs are active at any point in time, which is a very small percentage. So when we talk about scaling, try to think in terms of getting down to a reasonable sized data to begin with, and then look at using SQL federations. So if we were going to scale out our web servers, that last diagram we had where we just had one web server, we can just throw a web server in our app. And it's pretty easy to scale a web server out, isn't it? You add a server, you copy a whole bunch of files to your new server, and then you throw a load balancer on it, and then you start load balancing between the two servers. Who here does that in their web applications? Multiple servers, load balancer, everybody. Because it's so easy, isn't it? You complicate your deployment process a little bit by doing this, but it's pretty simple. Even CIOs can understand what we're doing here. And we can do the same thing with the middle tier, actually, if we have a bunch of web servers. But database servers are hard to do that with. Oh, another thing we can do with web servers is we can partition them. We can throw half our files of our app on one server and half on another server. And with web servers, you can even tie in specific customers to a specific web server. Who here has a web server for their internal users and separate web servers for their external users? For the same application, right? Yeah, really easy to do partitioning that way. But with databases, it's much harder. First off, you can't just copy a database file like a SQL Server file. It's kind of like removing the sword from the stone. We can't just do the file copy we did with the web server on the database server. We also can't partition it very easily. And the reason why is because our schema has all these weird interdependencies. At its core, SQL tables are just files sitting there. Only they have these weird relationships. They have foreign key relationships where we don't fully understand how they're related with each other. I mean, this one is a simple 6-table schema, but when it's 200 or 300 tables, sometimes the relationships are not immediately apparent to us. We have to kind of dive into it and research how these things are related. So if we try to do partitioning in SQL by default, where we said we're just going to put some tables on one server and some other tables on another server, our main problem with that is that we might have screwed up the relationships, right? Inter-server joining in SQL is a very hard thing to do. and sometimes a performance nightmare. Another problem that we have is we can try to not take tables and move them across servers. We can try to keep all of our tables on multiple servers and then use some type of mechanism like merge replication to keep those tables in sync with each other. Who here does that? Who here uses merge replication? Well, only one person uses merge. I use it all the time. OK, so merge replication says that if I add data to the customer's table on this database, we're going to, at some sync interval, move that record over onto another database. And that interval could be 15 minutes or an hour or whatever it's going to be. It's not a great scaling solution because when you add a load balancer, if you insert a record here and then you read out of it here, if you hit that sync interval, you're going to be reading the wrong record, right? You're not going to get your updates or your last insert. That's a bad thing, considering most users really want to see consistency in their data. They don't want eventual consistency in a relational database app, right? So they have an expectation that when they add a record, they're going to see their changes immediately. So merge replication with a load balancer is often not feasible for our users. So now let's talk about how federations in SQL Azure is a solution to these problems I just outlined. Anybody know what that symbol is? Oh, one person does? What is it? The United Federation of Planets in Star Trek? Yeah, that's the English term. Thank you. Oh, what's your native language?
German.
And what is it in German? Nice, right off the top. Yeah, nice. So this is our vocabulary for SQL Azure federations. In SQL Azure, we create a database, and it's just a standard generic database. But in federations, that database becomes our root database. Then we create a federation, which is one statement, and I'll show you that in a second. And then we start allocating federation members. And these federation members are independent databases inside SQL Azure. But they're all joined together. And the way they're joined together is SQL Azure is tracking what records are in what database for you, so that when you start partitioning your records out across databases, you don't have to keep a partition map up to date or current. You don't have to keep it in your application. Like if you're all developers, so you know if you didn't have this technology, you'd keep track of some partition map, and then every single time you wanted a record, you'd have to check your map and then go find the record, which creates a block point for you. But it's important to remember that these are all separate databases. And we can say, OK, here's a federation for my customer data. And I've got like 5 tables that host customer data. I have customers, orders, order details, a whole bunch of tables. And I'm going to put customer ID 1 through 9 in this database, 10 through 19 in this one, and 20 through 29 in this one. And all you have to do in your application is you have to tell federations, I want customer 12. And federation says, OK, he wants that database, and he starts handing you all the data back for customer 12. And you don't have to do any route mapping or anything like that. So what's going on behind the scenes is each database has that primary and 2 secondary servers that we talked about before. You know those physical machines that we talked about on the first slide? So in this situation where we have 3 federation members plus a root database, we actually have 12 physical servers in the background. Well, up to 12, actually. Because there could be some overlap, like maybe this secondary and this secondary might share a server. But SQL Azure guarantees that none will be fully overlapping in what they call fault-tolerant zones. So what that means is these 3 will not be the same servers as these 3. In fact, they guarantee that at least 5 servers will be shared between 2 databases. So up to 12, but I guess it could be as low as 9 servers in this case. But if you have 10 members, you could have up to 30 servers in the background hosting your data. Now, remember we talked about elasticity. We said scaling out means we're throwing hardware at the problem. And I just wanted to show you how SQL Azure is throwing hardware at the problem when we create federation members. So let's look at creating a federation. There's a 3 ways to create a federation. Okay, here's the SQL Azure Management Portal. Can you guys see that okay? Yeah? Okay. So I just need to take my database real quick, and I'm going to drop it. And this probably won't work, but we'll see if it does. Let's see. It worked. Nice. Okay. I didn't have to refresh. I thought I'd have to refresh. Okay, so that's my server name. I'm going to go ahead and create a database. And the database will be IkeDB because I'm creative. And then go ahead and click OK. Okay, so there's the Ike database. How many of you have seen the SQL Azure portal before? Oh, just a few. Okay, well, let me know if I need to go a little slower. But how easy was it to create a SQL Azure database? From the time you think that you want a database to the time you're using it is in seconds, isn't it? And that's fully fault tolerant with a primary and 2 secondaries. And you're up and running. Here's your connection string information with your fully qualified DNS name, and then your login, your username. I'm not going to tell you my password because I know you guys mess with me, especially during demos. But and then that's it. Okay. So we're going to click on IkeDB, and we're going to click on Manage. And Manage is going to take us someplace new. Let me actually close this one. Okay. So click on Manage. And I'm going to get a login page. I'm going to type in my username. And then it's going to open up the management screen. Oh, nice. OK. All right. So remember, we wanted to create a federation. And the first thing I'm going to do is use the Silverlight tool. This is SQL Azure Portal, which is written in Silverlight. You could tell that because of the % you saw spooling up. And I'm going to call my federation Customers Federation. And I'm going to choose a distribution name. In my case, I'm going to choose custID for customer ID. And I want you to remember that federation name because it's going to come up in my code over and over again. And now I can choose a data type for my federation name. And you have the choice between big int, unique identifier, and var binary. In my case, I'm going to choose int. And right now, our distribution type is grayed out because there's no choice. It's only range, which means you're going to do an inclusive to exclusive range of values that you're going to partition your data out on. And you'll see that in my code. So if this is a little overwhelming at first, just bear down with me, and we'll get to the code, and it'll be illuminating in just a second. So I'm going to go ahead and click Save. And now that federation is being created. Now that's one way of creating the federation, which is pretty easy. The second way is, this is SQL Server Management Studio 2012. And this is supported in that. So if I right-click on Federations and refresh, I'll see that Customers Federation that I had before, that I just created in the Silverlight tool. If I wanted a new federation, I could just right-click here and click on New Federation. Now, who here uses SSMS, SQL Server Management Studio, as part of their job? Yeah, a lot. Most of you do, right? OK. So when you click New Table, what do you expect to pop up in SSMS? A designer, right? Right. And in SQL Server, you would get a designer. But in SQL Azure, you never get a designer. Instead, you get a T-SQL script. There are no designers in SQL Azure. The designers don't work. So I hope you're comfortable with SQL if you're going to use this, because that's all you're going to get. And that brings us to the third way to create a federation, which is to just use T-SQL. So I can, in fact, I don't know why the templates always look so complicated, because the syntax when you type it out is actually pretty simple. It looks like this. Create federation, customers federation on custID int range. Is that font OK? Can you see that in the back? Yeah, good, thanks. So that's pretty easy syntax to create a federation and be up and running. And 2 seconds later, you'd be good to go. OK. So that's T-SQL. That's SSMS. OK. Here's the next thing we need to do. SQL Azure Federations requires a little bit of a schema change that you're not going to like, but it is what it is. You saw this before. This is my simple customers database. And you've seen this before because this is Northwind, and you guys probably have seen Northwind before. So here, this customer ID in the customers table is my primary key, right? And then customer ID in the orders table is what? Foreign key, right? And then we go to order details, and we see order ID, another foreign key to the orders table, right? In federations, customer ID gets mapped to that federated key, cust ID, the one I told you to remember before. So you have to tie those two things in together, which means that every table that you want as part of your federation splits needs to have customer ID in it. So we know it's here, we knew it was here, but we added it to order details. And if there's 30 tables that you want to split on your federation, you're adding customer ID to all 30 of those tables. And you're not just doing that. You're doing one more thing. I'll tell you right after this slide. It's important to remember this diagram where we talked about federation members. So in our root database, we're going to put tables that change that aren't being federated on. So like the products table isn't logically related to our customers table. So we wouldn't put products in all of our member databases. We would only put tables that were related to the federation ID. So customers, order, and order details in all three. And then in the root database, we'd have settings for our application settings, and we'd have products. And then we have one extra table you might have noticed in our schema, which is called the customer types table. And that's a lookup table, right? That lookup table says, is this customer an internet customer or a retail customer or a corporate customer? We would put a copy of that table into each federation member, and we would keep it synchronized. We would say, if I add a new customer type, we need to add it to each federation member. Why do you think I'm doing that? Yeah, performance. I'm doing it because database joins are faster than what I'm going to have to do if I want to join products to order details. I'm going to have to bring the data back into my app and then merge it in my data sets in C#. I'm not going to be able to write T-SQL to join those together because it's cross-server and cross-databases. So the next thing that we're going to do is choose a federation key, which you saw me do. Remember cust ID and remember the data type. Really, the two that are being used in the field right now are either one of the integers or a unique identifier. And there's something you need to know about the integers. Because the integer values are across databases, we don't have identity. Identity would be useless, right? Because we could repeat identity in the federations. There would be no way to track it in between. So that means that if you're going to use identity, you need to have some type of master key service where you're either pulling a table or you're pulling some web service or something that's keeping track of your new integer. And that's reasonable. I mean, you can do that if you want, as long as you're aware that that's going to become a block point for your application. Or you could use unique identifier. Unique identifier allows us to use the new ID function when we create new keys, which means no block point, right? Every server can create their own keys, and we're fine, right? But there's a bad side to unique identifier. Well, there are a couple bad sides. Anybody know them? Indexing. You guys talk so soft here. I thought you guys were boisterous. Do you guys need a drink? OK. Somebody said indexing. What's the problem with indexing? Fragmentation. Nice. I like the SQL expertise in the room. Yep, that's one problem. What's the second problem? Somebody whispered it. But no, what is it? Oh, how long it is? Oh, it takes up space in the indexes. That's true. That's a problem. But unreadable. OK. And you say unreadable, and I say non-sequential, right? We use those numbers. If somebody says, I want record ID 45, you get an idea of when it was put in the system, and you get a small number to work with, where you know you got the right record, right? And unique identifier is big and non-sequential. Yeah. So just be aware that there's trade-offs, and I'm sorry that there are, but there's trade-offs in a lot of things. OK, let's create the schema. So I'm going to go back to my Silverlight management tool. Okay. And I'm just going to I'm going to open up a query that I already have for you. That will create my schema. And I want you to take a look at the very first statement here. And you know what? I'm going to zoom in so you guys can see it. So you see create federation. You know that one. But we've already done that, so I can go ahead and delete that. This is a use federation statement, and I'll explain that in 2 seconds. Here's a create table, customers. And you guys have seen this before, right? There's my column list. But take a look at this last line here. Federated on, cust ID equals customer ID. This is my federation key matching the primary key of my customers table. And they need to share the same data type. So remember when I created it, I said int, right? And it's an int primary key. And I'm doing that on my customers table, and I'll do it on orders, and I'll do it on order details. But I want to come down to order details and show you something. Remember, I promised you I'd show you something weird that you'd want to know about? Okay, here's the something weird. Here's order details, order ID, customer ID, right? I told you that was going to happen. We were going to bring the federation key into the table. Product ID, but what's going on here? One thing that bothers me about the Silverlight tool is there's no line numbers. And it's hard to like pair and teach when there's no line numbers. But this line all the way down to the bottom, what's going on? What am I doing in those lines? Yeah, composite primary key, right, which means I'm adding the federated key into my primary key in all of those tables also. So be aware that that's got to happen. And then I'm creating this lookup table. Notice that I'm using my customers federation, and I'm creating the table in the federation, which means I want that table to replicate when I create my federation to everywhere. But notice that there's no federated on statement like there were on the other tables, which means that this table is not going to get split the way the other tables are going to get split when I need to add members. Then I'm creating foreign key relationships to that reference table. Okay, and then finally, I'm using the root database, that IkeDB that I created, and I'm creating settings and products, and those are just root database tables. Okay, so you saw that. Let's go ahead and run that, and hopefully we get all greens. Uh-oh, we didn't. What error did we get? Could not find stored procedure products. What does that even mean? So create table products. I have not seen that error. Hang on one second. Let me just see real quick. I don't know. Oh, was it highlighted? Oh, it was highlighted. OK, so a bunch of greens that tell me all those tables got created. And now I'm going to go ahead and load the data. And I have a script to do that, so we don't have to watch me do that. And this is just standard T-SQL that you know about, where I'm just going to use the federation and then load a whole bunch of data into it. Nothing big here, just a bunch of inserts. So I'm going to go ahead and run it. OK, a bunch of greens, and I've loaded the data. OK. Now, we've got a whole bunch of data in my root federation member, but notice I only have one federation and one federation member. So what I did was I created my federation and I loaded it with data, but I haven't split anything yet. That is a great practice. If you're going to migrate data into federations, load it first and split later, and then bring your application online. Don't split first because you just really complicated your loading practice. Now, if I have all my customers in one federation member and I need to split it out, the big question is, how do I choose how to split it out? And you can see up here on the board, you can split based on the size. We talked about that, you know, that 150 gig size limit. We just split our largest members out so that we have like half in each. We can split on load. Maybe we want better performance across servers. And we can split on politics, which is some manager just tells us how to split and doesn't really ask us why or how that's going to happen. And I've seen it split all of those ways. Let's look first at split on size. So here's our demo 3. I'm going to go back to the Silverlight tool. And I'm going to go to my database, which is right here, IkeDB. And remember that federation here? Can you guys see that okay? Everyone can? Yeah? Okay, good. So here's customer federation, and I'm going to click this arrow right here, and it's going to bring up this window. And you'll notice, like I told you, I only have one federation member, and here it is in size from 0 to 150 gigs. So imagine I had 6 of these. I could see which my biggest one was. I could say, oh no, this federation member is coming up on 150 gigs or 100 gigs, and it's time to split it. If I hover over the federation member, I get some information. And the information is pretty useful if I'm looking at splitting based on size. And that is, it tells me my used space. Here I'm using 5/1000th of a gig. And it also tells me what percent is free. I'm 99% free. And what percent is filled. But let's just pretend for a second that I've got a ton of data in there, and I want to split that member. So I know that member is Customers Federation, and it's the smallest member that I have. Okay, it's my 0 member. So what I can do, excuse me, let me go back to that tool real quick, is I can open up a new query, and I can run this script that I wrote, and I'll explain that in a second. I'm going to split based on big tables. And there's 2 queries here. The first query is it tells me my table size. And this is a tricky query. You don't have to know all the ins and outs of it, but I do want you to look at the results of it. And it'll be in the slide deck too, so if you ever want to use it, you can. Okay, I'm going to highlight it and execute it just like I can do in SSMS. And this query tells me my biggest federated tables, order details, customers, and orders, with order details being the largest one. Now, this is an interesting thing here, how we're splitting on size. You know, we're used to thinking, oh, this is my customers federation, and I'm federating on customer ID. So I'm going to go to the customers table, which should be my biggest table, and I'm going to look down it, and I'm going to split it right in the middle. So if I have 100 customers, I'm going to split at customer 50 and call it a day. But the reality is my customers table is not my largest. In fact, it probably is going to be my smallest when the application's in production, right? My largest table is going to be the order details table. And I don't want to split at customer 50. I want to split at the customer that does the most orders. What happens if one customer does half my orders? I want to know who that is and give that customer their own server. So I know that my big table is the order details table, and then I'm going to run a second query. And that second query is this one right here. It uses a CTE. Hang on one second. Let me just go up and get this use statement. Come down here, run it. And it tells me this query uses a CTE with the intile function, so it breaks all of my customers down into 2 groups sequentially. And it says, give me the first half is tile 1 and the second half is tile 2. So we know tile, right? If you don't, let me know. And then it says, take a look at tile 1 and give me the highest customer ID. And the highest customer ID for tile 1 is customer ID 6. And that's the one I'm going to split on. So I took order details and split that table in half and got the highest customer at the halfway mark. So I'm going to split on 6. Let's go ahead and do that. I'm going to take customer ID 6. I'm going to go back to my federation. It's right here. And notice when I clicked on my federation, I have split right here. So if I click split, it says, what do you want to split on? I want to split on 6. I go ahead and click split, and the split process begins. And if I hover over it, you can see that it's splitting. Let's see. Uh-oh. Let's close that. Highlight this. It should be splitting. Let's see if I refresh and I can see it. There it is. Do you see that kind of split in progress with the 3 dots there? OK. I can also monitor that in Transact SQL with a DMV. And that DMV is DM Federation Operations. And if I run it, it will tell me that I'm 0% completed in my split. Now, here's the cool thing about a SQL Azure Federation split. It's online. which means the old database that was using order details is currently accepting transactions, currently running. When this thing is ready to be completed, it's going to take that one database and right now split it into two databases and hold them in the background. It's going to wait until that split is complete, and then it's going to cut over to it. Take the latest transactions and bring them back down, and then bring two databases up where there was one. And then the connections are going to be reset, but it's a cloud application, so hopefully you have some type of retry interval, and you're just going to reconnect, and you're going to see your data, and you're not going to lose any data, and you're not going to have any downtime. So that's one of the big advantages of SQL Azure Federations is that split is online. OK, let's see if it's finished yet. It finished. You notice there's no records down here, so that tells me that the split completed. And if I go back to the Silverlight tool, to my federation, and I refresh, notice now I have two federation members, one that starts at 0 and one that begins at 6, with half of my orders in each one of those federation members. I just showed you how to split based on the Silverlight tool. I can also go into SQL Server Management Studio, and I can look at my federation, right-click, and just split the federation member. And what's this going to do? You guys know. Yeah, it's just going to give me a code snippet, which is what it does here. And again, it overcomplicates it because really the syntax is alter federation, customers federation, split at 6. That's it. No parens, nothing. Just split at 6 and you're done. And then it runs the same thing that we just did in the Silverlight tool. So you could do this through T-SQL also. OK. Another way you can split is you can split on load. This is a really popular query that SQL DBAs use. I got this from Pinal Dave. Do you guys know who that is? Blog writer. He just has this on the web, but people use it all the time. And it uses the DM exec query stats, DMV. And it just tells us what our most popular queries are. And if we run this, we get results that the Silverlight tool actually gives us. They probably use the same query, actually. If you click on the federation and you click Overview, View Summary, I can see my federation member and, is it full and a few other things. But I can click on Query Performance, and I get these results. And what these results do is they tell me my most expensive queries, which ones are getting executed the most, and which ones are costing me the most CPU cycles or load. And I can take a look at that. I can get rid of all of my SP reset connections that litter that thing all the time. And I can take a look at the tables that are actually being abused in my application. And if some of those tables are federated tables, that might be a good candidate to look at splitting and figure out where the load is coming from and split that load off into its own federation member, thus hopefully solving the performance problem. So be aware of that query. It's in the slide deck, and it'll be available to download. You can also decide to split on politics. If you split on politics, I've seen political decisions happen all the time. And the interesting thing about political decisions is those are the decisions that nobody can remember why we chose to do it that way. Right? Usually when there's a technical reason, we know the pain, and we solve the pain, and the pain is memorable. But somebody's fiefdom that they're protecting is not memorable to us. There's no value. So if somebody comes and says, you're going to split on order date, that's what you're going to do. You better write down who, why, and when they said that, and keep that around so that when that guy becomes a vice president of another division, you can tell the new guy why we did things the way we did them. Because they'll ask. That'll happen in 6 months, by the way, after you make the decision. 6 months is a perfect time for that to happen because it's about 2 months after anybody remembers why we did it, and soon enough that you remember predicting it would be a problem. So good enough to bite you. OK, we already did the split, and we monitored the split. And now we're going to talk about the use federation statement. So I promised you that we would get back to this use federation statement because it's a tricky one. And it's kind of cool. Yeah. OK, here we go. Is it coming up? What's wrong with IE? Let's bring, did IE just shut down on me? It might have. Okay, that's okay. I can do it here. So let me go ahead and open up my new query. Hang on one second. What is going on with my dialog boxes? Do you guys see this? Uh-oh, the dirty truth just came out. Did you guys know I was running on a Mac? Okay, there we go. Okay, I'm going to open up a new query, and I'm going to open up my use database, my use federation statement. Okay, so, and you can read that. You can read that in the back. That's nice. Wow, these are nice projectors. Okay, that's what you get at TechEd. Nothing but the best. So that use statement looks like a use database statement. And we use database statements to control what database we're on. But remember, SQL Azure is a tricky little bugger. Oh, I shouldn't say that. I can say that in the US, but I can't say that here. So SQL Azure says that you could be on different servers. So if you have database A on one server and database B on another server, even though they look like they're one logical server, and when you go to SQL Server Management Studio, you can see them in the list if you're on the master database, you can't use the use database statement to switch between databases in SQL Azure because you're actually switching servers. And when you're switching physical servers, which is why use database doesn't work now and likely never will work, right? But use federation, just to kind of confuse you guys, that actually does work. And this is our ability to switch between federation members. So if you look at this first use federation statement, use federation, customers federation, cust ID equals 0, and then don't worry about that stuff on the end right now. But what I can do when I use the root federation member is I highlight it, and I execute just those top 3 lines, and I get the first 5 customers. That's what you'd expect I would get, isn't it? Because remember, we split at customer 6, right? So you would think that the syntax would be use federation, customers federation, cust ID equals 6. But I actually used cust ID 10 or cust ID 7. We could change it to any number you want. Why don't I do like cust ID 8? And then highlight that and execute. Oh, excuse me. F5 is what I just did, by the way. I've been working with this product for months and months, and I do that every time. OK. I execute that, and look, I get 6, 7, 8, 9, and 10. Now, notice that I said cust ID 8 and then executed it, and I got everything from the member. And I'm doing that to demonstrate to you that you don't have to keep track of your member map. You just have to say, I know I have a customer, and I want all the data related to that customer. And to just kind of prove that you can do that, I want to query a few other tables doing customer ID 8. I'll do select star from orders, select star from order details, and then highlight these lines, and then execute. And by the way, the tool is a little bit different than SSMS. Here's the customers, here's orders, and here's order details. And notice that it's off of the partition key, off of customer ID 6, 7, 8, right? I'm getting everything based on this use statement, cust ID equals 8. So that's pretty slick, I think. I'm going to take those tables that I just added, copy them, and move them down to this. And I'm going to show you a key difference. OK, just for the sake of continuity, I'm going to use customer ID 8. This statement looks just like the statement I just executed, but I want you to pay attention to this clause in the use federation statement. It says with filtering equals on. The statement before was with filtering equals off. When I click on run, notice now it's only giving me the records for customer ID 8 with no where clause. And if I click here, here are the orders, and here are the order details for that customer ID. No where clause. So When you use a use federation statement with filtering on, you're saying, take a look at my cust ID and only give me the records related to that cust ID on all of my tables that are federated. And then again, off, it gives us everything like you already saw. One more thing about the use federation statement is you can say use federation root with reset. And what that does is say, I want to get out of my federation members, and I want to go back to my root database and start using tables that are in the root database, like the products table I told you about earlier. So if I highlight that and execute, that's my products table outside of my federation tables. Root table. OK. You feel like you have a handle on the use federation statement? It's new, isn't it? You've never seen that before. Or maybe you have. OK. Yeah.
Can you leave the root and select where customer ID equals 6?
No. You have to, if you say cust ID equals 6, you're saying I don't want the root. I want a federation member. Yeah. Yeah, that's going to, I've got a demo for that if we have time, I'm going to show to you, which is kind of cool. Yeah.
How do you get the list of all customers then?
Ooh, that's a good question. You're like Dean Martin to my Jerry Lewis. I'm going to show you that. OK? Yep. You're a good straight man. Anybody else? OK. Thanks for those. All right. OK, so now let's take a look at working with the data. We're going to take a look at quick CRUD operations. But before we do that, you need to answer his question, which is, when you work with the data, the very first thing you need to do is get a federation ID if you're going to work with data in the federated tables. So you need to have some way of doing that. And then you're going to do something with it. You're going to either insert it or update it or delete it or read it or do whatever you're going to do with it, right? So in order to get that federation ID, you can either fan out query to find it, or you can store that ID in the root table. Remember when I talked about the master key table? And I said, if you want to keep track of all of your keys and who those keys belong to, store it in the root database, and then query that, and then that will tell you what federation member to go get. Which means you basically have to keep that small 2-column table consistent with whatever's in your federation members. Which means that that small master table is going to be your choke point. Or you can do both. You can say, I want to fan out for some queries, and I want to use the master table for other queries to kind of avoid the choke point. Maybe you only have the master table to give yourself a new ID, like a new integer, because we don't have identity. And you use fan out to do any kind of grunt, brute force querying on the customer's data. So let's take a look at that. Now, I'm going to kind of play with something real quick. I'm going to ad hoc demo, which means I'm probably going to blow up and make an idiot of myself, but that's OK. I'm willing to do it. So let's go back to that Silverlight tool and create a new query. And I'm going to create a table, create table pound temp data, customer ID int, comma, customer name, varchar 200, and then go. And then I'm going to use federation, customers federation. Let's see. Yeah, cust ID equals 0 with reset. Filtering equals off. And then I'm going to say insert into temp data, select customer ID, customer name from customers. OK, so what I'm doing is kind of a T-SQL fan out that's going to fail. So I actually don't want you to remember this. I want you to kind of think about why this is going to fail. It might be a syntax because I screwed up the insert statement, but let's click on run. And it says, pardon me? Oh, right, OK. Well, that's OK. I don't, right. Excuse me? Oh, excuse me, you're right, thanks. There we go. Thanks. But that's OK. I don't want this to work, and it's not going to work anyway, because we'll get this error, which is what I wanted, which is it changed the database context. This is the actual database name to the federation member. It created some terrible name for us in our new database when we created the federation member. And then it tried to insert into temp data, and it said invalid object name temp data, when I just created it in the session. You guys have worked with temp tables before, right? So how come I can create the temp table, but now I can't find it? What's that? Right. That table now exists in the root federation. And when I switched to a federation member, I got a new server. Where are temp tables stored on a SQL server? TempDB. Yeah, I heard somebody whisper that. I feel like I'm so loud, and then I get little mousy whispers. If you girls were at bars, that would be impossible to pick you up. So yeah, TempDB. That's right. And there's 2 different TempDB databases, and I created the table in the wrong TempDB, and every federation member gets its own TempDB, which means that this kind of fan-out thing that I'm doing is never going to work in a store procedure because I switched servers, right? So, and there's no linked servers in SQL Azure, which means that if I'm going to do fan-out, I have to do it inside C#. I have to do it inside my application. I don't have to do it inside C#. I do if I'm a .NET developer, but OK. So I'm talking about inserting data, and I want to know what my new customer ID is. And so I'm going to use a master table to begin with. So I want to show you using a master table, and I want to show you fan-out. The first one's going to be an insert using a master table, and the second demo is going to be a query using a fan-out. So real quick, what this does is we know console write line. We know string.format, which is going to take this string, and it's going to look for this variable, and that variable is going to call this method. And this method is in my demo insert class. So let's take a look at that. So this is pretty standard code, you guys. Let me know if you need me to explain it. So the first thing is I use a connection. I open up my connection. I have a command. My command is the use federation root command, where I execute immediately. Now I have a new command, which says, give me the max customer ID from the customer list table. What's the customer list table? Well, let's go back to the Silverlight tool. Let's do a new query and open it. And let's look at, this is a table I'm creating right now. That's the master table with my integer keys. Remember I said we're going to use a master table to find out the latest key? And I'm only going to keep track of 2 columns, customer ID and customer name. And I'm going to load it with data. So I'm going to highlight this and run it. I'm going to get an error because I don't think the table exists, but it added 10 rows. Do you see that? OK, so I'm just kind of prepping for the demo. And then let's just prove that that customer list is there. It is. See, all 10 are there. Anybody recognize these names? Did anybody watch Arrested Development? Anyway. So I want to show you 2 different results. I want to show you the customer list, and then I want to show you the customers table off of cust ID 7. So there's 10 customers, but notice in my federation member I only have 5. So I just want to prove to you that those are consistent and they're different data results. So I go back to C#, and what does it do? It finds customer ID 10. That was my last customer ID. It increments it. Then it does an insert in customer list, and then it uses the federation statement based on, and let me clear that because we don't need it, cust ID equals what? Cust ID equals 10, right? The new ID, which is right here, new ID. Actually, it increments, so it's going to be 11. Did somebody say 11 and I messed up? You did. I wish I could give you another poster. Did I already give you a poster? Dang. It's all I got. Sorry, man. OK. So then after I use the federation with customer ID 11, I'm going to insert it into the customers table and be done. And that's going to show up in a console app. So let's go ahead and press F5. And it says new customer inserted, number 11. Let's go back to the Silverlight tool, run the same queries that I ran before, and make sure 11, maybe Bluth, is down there. And then if I go back to my other result set, 11 is down there. So I did just add that record, and that's what I'd have to do. Okay, so that's an insert with the master table. Now, let's take a look at the query, the fan-out query. So let me go ahead and comment this out. Uh-oh. Okay. And then uncomment this out. Okay. Now, this is a little bit more complicated, but it's still really simple code. No one's going to find this code daunting. This is going to call this query called getAllCustomers, this function. And I'm going to get a whole bunch of customers. It's a list of customers. And then I'm going to iterate through it. And then I'm just going to console write line through those customers. And that's this code right here that I wrote. So this declares my return data as a list of customers. Then it creates a temp data set. And this is not anything special. The first thing it does is it goes to the root database, and it queries this table. This table is a DMV called Federation Member Distributions. And that table has all of my key values for this specific federation. I didn't have the where clause because I only have one, but usually I'd have a where fm.name equals customers underscore federation. Should be tacked on to line item 37. And in this case, I'm going to get two values back, right? I'm going to get 0, which is the first federation member. And what's the second I'm going to get back? 6, right. OK. So once I've got those two, I do some hokey stuff to find the row of the table. You've seen this code a million times. This is 10-year-old code. I could have used Entity Framework or something awesome, but I figure some of us know Entity Framework better than others, and why not just stick to the basics? So if I find my 0 and my 6, I'm going to iterate over that. And I'm going to feed the 0 and 6 into a use customer federation statement with cust ID equals either 0 or 6. And then I'm going to select all the records from my customers table from 0. And then I'm going to fill my data adapter into my data set, into the temp data set. And then I'm going to use link. And I'm going to create a new customer into my iList, my list of customers, right? And I'm going to fill the properties into the initializer. I'm going to close my connection, and I'm going to return the list where I iterate through it. So if I run this now, excuse me, you'll see all 11 customers iterate through. That's quick. That's not that slow. By the way, I'm not pre-baking the turkey here. This is SQL Azure. We went over the WAN in this janky, you guys saw that, this WAN's gone down several times all week, right? But we've gone over it. I found all 11 customers, the Bluth company, Sitwell Enterprises, everything, and it just returned like that. That's a very basic fan-out query. No async code. Were you guys hoping to see async code today? I could show you async code if you want, but chances are I'd lose half of you. But I can also make this asynchronous and fan out, really make all those servers work at the same time. If I had hundreds of thousands of customers on every server, maybe that's something I would want to do to get those query results back as soon as I could. Does that answer your question? There you go. Thanks for the lead-in. No, you cannot. Yeah, you can.
Since the split is an online operation.
Yeah.
But you actually need a code change for the federation to work. So you need web deploying.
You need a code change for federation to work. What do you mean?
If you have a front-end function that returns all customers.
Yeah.
And when you don't have split, you have like a basic select star from.
Oh, I see. So are you saying?
But when you have split it, you need to change the code so you get all the customers.
Right. Okay.
Correct.
Not quite. Okay. So let me follow. Yeah. Let me see if I've got your question right. Are you saying that if you have one member only, you're just going to do a select star from customers? But if you have two members, you then need to have the use federation statement, right?
Yeah.
That's what you're saying.
That's my question.
Yeah, yeah. But you're not saying if I go from 2 to 3, I have to do a code change, right? All right, right. OK, what you just said is right. I have never seen a federation with one member. By the time they get to the point where they're using federations, they have a reason, right? They want to use it. So all federations that I've seen have 2 members and potentially many more. So the answer is yeah, but this code would work with 1 member. It would just iterate through one time and give us the same results back and wouldn't be that much slower.
So actually, a code deploy at first when you plan to do a split, and then you split it, and then it will work.
Yeah. Well, no, this code will work even with 1 member. It might. It has a couple extra constructs you wouldn't need otherwise, but it will work.
But from the start, I have like a web application that was pretty basic from the start. It only had select start from customer.
OK.
And then I need to do this split operation, a quick federation, and so on.
Then you have to change code.
Then I have to check. Yeah.
Right. OK, so that brings me to a question you didn't ask, but I should probably answer anyway. And that is, federations are very difficult to implement on an application that's brownfield. So if you greenfield, it's a great solution. But on brownfield apps, it's tricky, and it's going to require significant rewrite. Now, ideally, you'll have some ORM that you're using that will make implementing federations much simpler. And there are ORMs that do support federations. So an ORM is an object relational mapper, where you've got a layer in between your application and your database, in which case you're letting the ORM generate the SQL code. And the minute you plug in federations into it, it just generates your SQL code differently than it was doing it before. And you don't have to do any rewrite. If you didn't use an ORM, the data migration is very tough to do. But it is possible. In fact, I'm going to show you. It's going to require rewrite, but it is possible. So I'm going to create. I'm going to use a tool that you can get off Codeplex called the SQL Azure Federation Migration Wizard. And I'm not going to go into a lot of detail on this, but what you can do is connect to a server. And in this case, this is my data source. And I'm just going to say, yeah, localhost is fine. Yeah, MasterDB is fine. OK, there's a bunch of databases there. And then I can choose, like, I want Northwind and customers, right? And then I can go to SQL Azure Federation Target, where I connect to a server. And if I go back and find my server name, this one right here, this Q3H, actually, let me take the whole thing and go back to my tool and paste it here. Take this. When you use SQL Azure, you have to append your username with your server name, like that. And then the database will be IkeDB, and click Connect. Let's see. Oh. Ellis Ike. There we go. Click Connect. Again. Oh, thanks. I don't know what I'm doing. I can't get my name right. Things are bad for me. There we go. Thank you. OK. So notice it found my federation members. It found the root. It found cust ID min to 6 and cust ID 6 to max. And so I could take my customers table, and as long as the data type's matched from the source table to the destination table, it'll split it and load it for me automatically. And this will work. And this is how you can get existing data into federations. It doesn't help you with rewriting the code and getting the use federation statement in. But if you go back to that code, just to make it so that it's not super daunting, this code is terrible code, right? I wrote this code all in one procedure just so I could explain it easily, not because it's great code, right? So I should throw that into its own function, take out maybe the federation name and parameterize that, take out whether or not I want filtering, yes or no, and parameterize that, and then just call that in my, probably in my data layer. Hopefully I've got a generic SQL command in my framework that I'm using, and just call that right before I execute anything in my data layer. If I've written the application with its own data layer, this might be a little bit easier. If I've thrown concatenated SQL code that's susceptible to SQL injection all over my ASPX pages, then I'm totally hosed, and I'm not going to be able to probably use federations. Okay. Now, we've talked about elasticity in federations, mostly like my waistline expanding, right? We've only added members. We haven't talked about dropping and merging members. In this version of SQL Azure Federations, we only have drop, which means there's no merge, which means if I have 2 members and I want to create 1 member, or if I have 3 and I want 2, or if I have 4 and I want 3 or 2 or 1 or whatever, right? I have to manage that by hand. And that means there's going to be downtime, because by hand means not online, which means I'm going to shut everything off. I'm going to bring all those tables together by hand, and then I'm going to bring the new member online, and then I'm going to drop the other 2 members, which is not easy, and you will have downtime according to how large your data is. So you can also use the SQL Azure Migration Wizard to manage the merge if you wanted to. But it's going to be a drop statement. It's really simple, drop federation, the federation member. Okay, I want to show you a little bit about navigation, just to kind of show you how easy this is. First off, this is back to the Silverlight tool. If I click on the database and I click on my federation again like I did before, and I've got my 2 members that you've seen this already, right? Okay, I want you to just notice that I've got the overview we've shown you, and I also have this query button that's kind of cool. And I'm going to go ahead and click New Query. Okay. You've seen some ugly code here. You might not have known that it was ugly code, but I'm just going to show you already. Do you see this? Do you see how there's a use federation statement here in my code right here, and then an insert, and then another use federation, and then an insert, and then another use federation? It's really repetitive and ugly. The reason why I have that is because I want to be able to highlight and execute separately. In case I had a problem, I wanted to be able to grab a command, execute, grab a command, execute. If I don't have those use federation statements, in order to execute them separately, it will lose the context where I could be in the wrong federation. So what that did, what that query that you just saw did, and let me see if I can find it again, Untitled 5, is it threw the use federation outside the query window and allows me to have a script with a whole bunch of inserts or selects or updates or whatever I'm doing, and not have to have the use federation on every single one. Now, that's kind of a handy thing to know in the Silverlight tool. It'll save you a lot of time and aggravation. So that's one tip. Another tip I have for you is just finding your schema is a little bit counterintuitive. So if you're used to SQL Server Management Studio, you saw me create all those tables and all that data, and now we want to find out what I did, just because we're going to forget when we get to 200 tables. So this is my root server, that Q3H98 whatever, and then the IkeDB. And if I open up the tables there, you'll see the tables that exist in the root, right? I'm seeing customer list, products, and settings, the ones I told you I was creating in the root. But I'm not seeing my federated tables. If I come down to Customers Federation and right-click, I can connect to Federation Member. And when you connect, it says, which one do you want? And the one I want, just for this one, I'll say 6, and I'll click OK. And remember that big, long name? Remember that real ugly, when it switches database context, it gives me a really ugly name? It's going and finding that ugly name, and it's putting it in Object Explorer and SSMS. And then if I open up databases, and then I see IkeDB Customer Federation 6 to high, that tells me what federation member I'm on. And if I open up tables, that tells me what tables exist in this member versus what exists in the root versus what exists in any other member. And here's a tricky thing. Schema does not have to map once you start splitting. So you can start dropping and adding columns and tables in different federation members if you wanted to. Any idea why you'd want to do that?
Customization on different customers.
Yeah, for versioning, right? If you have one group of customers on one version of your app and another on a different version, you can have different schema if you wanted. I would not do that. I would avoid that because one day you're going to want to merge. Because every single member charges you. Remember I showed you the prices up there? And I said if you have data this size, it's this much money. That's per federation member. So if you have 5 1 gig members, you're going to be charged for each one of those. Or 5 10 gig members, you're going to be charged for each one of those. So I would keep them together so that if the bill gets too high, you can collapse them back in one day. Excuse me. Okay, here's some app building good practices. Do I really only have 3 minutes left? Oh, my goodness, I cannot believe it. Okay. You saw me say load data into root and then federate. Good for new applications, but tough to do in existing applications. I showed you the migration wizard. Reference tables should be kept in sync. It's a bad practice to put the products table as a reference table everywhere because you do not want to have to write the synchronization code when you add a product. It's good for customer types because we hardly ever, it's good for state codes. It's good for, zip code lookup or whatever the equivalent is in Europe. But I apologize for my ignorance. But it's not good for tables that change a lot at the moment. Make sure you add a retry interval to your connection open because if you, SQL Azure will drop at the split complete and you're going to want to be able to retry and not show the user a bubbled up error that the connection dropped, right? So retry a few times before you bubble up something into a log. Be aware that SQL Azure will throttle you. As you add federation members, you're adding servers. And those servers are multi-tenant, not with your customers, but with Microsoft's customers. So what that means is you could have a customer that's bad behaving start causing throttling problems for you. So you need to be aware of how to deal with throttling. And the big way to deal with it is to be able to, first of all, not hog resources yourself, not a lot of fan outs if you can avoid it. Be surgical about what data you're pulling back. And then be prepared to retry again. SQL Azure has some new errors related to throttling. SQL Azure will throttle you if you use too much CPU, if you use too much of the database log, if you use too much disk I/O, you'll get throttled. So be aware of the errors that show up. And then I want to show you the performance tuning slide, and then I want to show you the roadmap. So this is a bunch of stuff on throttling, and you can download these slides and look at it. In SQL database performance tuning, you do not have SQL profiler, PSS diag, no X events, no error logs. But what you do have is you can index tune. You should have covering indexes, particularly over your where clauses and join clauses. In SQL Azure Federations, be prepared to sort data on the client because you're not going to be able to sort across federation members. So be prepared to write that code. Look at minimizing round trips because you're dealing with latency in the cloud. And if you can't minimize round trips, look at putting your web app in the data center near your data. You can use a data center close to your location. There's one here. And that's the big stuff that we've talked about some of the others already. Also, the support is a phone call away. So if you have a bad performance problem, you can call support and they'll help you with it. What's coming in SQL Azure? They just released improved latency for the use federation statement. Right now, federated tables do not support timestamp, row version, or identity, but support for some of those. Identity, I think, is going to be supported soon. So be prepared for that. Database backup doesn't currently work with federation members. Your databases do get backed up, but they don't have a copy database command where you control the backup. It gets backed up at the data center, and the data center can restore it, but you can't restore it. But coming soon will be support for backup for federation members. Also coming soon is point-in-time restore on federation members, but that might be a little farther out in the future. And then geo disaster recovery. Right now, you know those 3 servers that you get per database? That's all in one zone. And then, I'm all done. But soon you'll be able to choose different geographic locations for your backups. So you'll have kind of earthquake-proof fault tolerance. You will be able to data sync reference tables. The minute this feature is released, you can take the products table and put it in your federation members. Data sync is merge replication for your reference tables. So you can keep your products table eventually consistent. And then here's what I think should happen with federations. I think that we need a merge that's online, and I think we need fan out without us writing the code. Remember this at the very beginning of our demonstration, we said that the SQL Azure Gateway service gets you to the right machine when you use a database. In my opinion, it'd be really cool if that gateway service would fan out federations for me. I am not the original thinker of that. It's all over the forums and blog posts, and a lot of people have thought that that would be cool. And I know the product team has heard it. So I don't know if it's on their roadmap or not, but I wouldn't be surprised if they're thinking about it. If you want to contact me, here's some contact information for me. My email address is ike@ellisteam.net if you want to email me. Or you can tweet and I'll email you back. Remember I told you about my user group. Some of you were here for the user group at the beginning of my introduction. That's at sdtig.com if you want to learn more about it. I know you're not going to come to San Diego to read our book, but I want you guys to get excited about starting a user group like that in your areas. Because I think we get books for free. Did I tell you the books all get donated by the publishers for free? So if you want to start a user group like the one we started in San Diego, ping me and I'll give you our contacts with publishers so you can get free books and get a whole bunch of people reading the same book together. I appreciate your time, and if you have any questions, let me know. But thank you so much for spending your afternoon with me.